Hello everyone, I'm Kim Langen, CEO and co-founder of Spirit of Math. Today we're going to be doing part 2 of addressing the needs of the high-performing student. In this part, we're going to look at specific strategies to use when sitting down with your child. So in particular, the role of drills to build automaticity and fluency of number facts, how to develop the sense of discovery so that you can develop the confidence and help your child take risks, your language and how it helps to build conceptual understanding, procedures. We're going to quickly look at the importance of developing the skills gradually so that complex procedures appear obvious, and then focusing on ideas to develop the mathematical thinking. So first of all, we're going to be looking at our drills. And big part of drills is the timing. The timing trains the mind to think faster. So not only do we get an automaticity and fluency of number facts, but in fact the brain really, we see a difference in the speed of the brain and what happens with the kids when we do that. Now, our drills. In grades 1 through 4, we have a grid-like pattern for the different types of drills. This is a multiplication drill. For grades 5 and 6, it's a 10-minute drill. This is actually a 5-minute drill. And basically what you do is you take the numbers along the index row, which are the 3, 5, 6, 2, and 7, and you multiply each of those numbers by the numbers in the index column, and the index column would be the 875 all the way down to the 266. So let's just have a look at how you do this, and then I'm going to discuss how the fluency and automaticity is developed by doing this. So first of all, you take that 3 and multiply by the 875, and you start with the 5. So 3 times 5 is 15. You put the 5 down, you carry the 1 in your head. We encourage the kids to hold the number in their head so that they're doing a couple of different things at the same time in terms of the calculations. They're basically doing a calculation and holding something in their mind. So two processes are happening in their mind at the same time. So 3 times 5 is 15, carry the 1 in your head. Then you do the 3 times the 7, which is 21, plus the 1 in their head, gives you 22. Now you're holding the 2. And then you would do 3 times the 8, plus the 2 in your head, which gives you a 26. So the kids would write this down. They would then go on to the 3 times 148 and the 3 times 411 and put their numbers in the appropriate cell as they work down. Then they would start up with the 5, and they would do 5 times 875 and put the number in there, and 5 times 148, and work their way down. And the same with the 6 and the 2 and the 7. They have 5 minutes to do this. Now what's really cool is that when they're doing this, if you just even look at the 3 times table, what's happening is they're using that 3 so many different times. And when they're using it so many different times, they're going to get an automaticity and fluency of the number facts rather than like just naturally, because they're constantly using it over and over again. In fact, we even let them use multiplication tables when they first start so that they aren't just using their fingers as an exterior manipulative. They're actually learning to get it so that it's right inside and these numbers, and it becomes automatic and fluent. So 5 minutes, the kids track their progress on a progress graph. You don't do a drill just to do a drill. They have to see the progress. So each time they do a new drill, the numbers may be slightly different along the top and the bottom for the index columns and rows, but they keep going back to same types of numbers or same numbers, and we keep doing them over and over again so the drills get better and better. Notice that we didn't use the number 4 or the number 8 or the number 9 in this particular drill. In other drills they would have to know those. So and in the grades 5 and 6, all of the digits are used along the top so that they get practice with all the digits. This fluency and automaticity allows the kids to get to other ideas, and this is why it's critical that we do this. In Spirit of Math, a big part of our curriculum is the fact that we have the 4 different elements. The drills themselves is the one part, and if the kids do not have that fluency and automaticity of number facts, then they're going to have difficulty when they get to the core curriculum, because we expect the kids to be able to multiply, divide, add very quickly so that they can add it to the skills that they have and that they need for the core curriculum. And also we require that automaticity so that they can get into the higher level thinking that's needed for the collaborative group work and the problem solving. The conversations change immensely from what is 3 times 2 to, oh, we can use 3 and 2 in this example or that situation. And the same in the problem solving. They can get to the actual reasoning as opposed to just trying to figure out what the numbers are. So it's a hugely important. And for high-performing students, it's critical that they have the opportunity to develop that automaticity and fluency. Okay, now we're going to look at strategies to use when sitting down with your child. And the very first strategy is to develop a sense of discovery. And when you develop a sense of discovery, it's important that you've got good material to use. So and the other thing I just wanted to say right now is mathematics, so many people think about it as just doing the questions in mathematics, as opposed to discovering, wow, there's all these patterns, there's all these things that you can do with numbers, and they all kind of combine together, and they come together to form some really cool ideas and different things you can do with numbers. So we want that sense of discovery to be an essential part of taking mathematics. And if the kids have this, they get much more excited about mathematics. So I've got a question here. What is the units or the ones digit of 4 to the exponent 526? Now this seems like quite a crazy question, and we can ask this with grade 4 kids, grade 5, grade 6 kids, and even the high school kids if they haven't seen this type of idea before. And the reason why we make it so large is so that you can't use your calculator. Now with computers the way they are, you could probably punch it in and find it out, but we want the kids to be able to think through this, and this is truly mathematical thinking. How can we solve this without using a calculator and without doing a huge amount of calculations on our own? Well, there's other ideas here that are going on. So the very first thing that we try to do is get the kids to say, well, what if you started doing it for smaller numbers? And let's make a chart. If you did 4 to the exponent 1, that's 4. 4 squared is 16. 4 cubed is 64. 4 to the 4th is 256. And we encourage them to keep going until they start to see or discover a pattern that's happened here. And as you can see very quickly, what's interesting isn't just the big number. For example, 4 exponent 6 is equal to 4,096. Well, all we're interested in is the ones digit. And because we're just interested in the ones digit, well, that really changes everything, because now all we have to do is look at the ones digit. And if you notice, the ones digit goes from 4 to 6, 4, 6, 4, 6, 4, 6, and so on. And that, it has a 4 if the exponent is odd, and it ends with a 6 if the exponent is even. So 4 to the exponent 526, the exponent is even, so it will end in a 6. Did you get that yourself? I hope you saw that, and it's really cool when you get the kids to actually figure this out on themselves, because they figured, like, they've discovered this pattern. It was already there. They discovered it. So that's the difference between creating something wholly new to discovering something that's already there. So now that they've got that, now we can build their confidence and ask this question: what are the last 3 digits of 5 to the exponent 112? Well, now that the kids have figured out how to do the simpler one with the 1 digit, now they know that they can probably figure this one out. So let's do it together very quickly. We take the base of 5 and we add on the exponents, and then we just do the calculations for the smaller numbers, which is here. And do you see a pattern? I hope you do, because the pattern is the last 3 digits change from 125 to 625, 125, 625. The exponent on 5 to the exponent 112 is even. Even 5 with even exponents always end in a 625. Isn't that cool? So your answer is 625. Now, once the kids see this, and you can start asking, why does this happen? Because that pattern was already there, you discovered it. Now it comes into other types of questions and other ideas pop up. This is what the high performing and the gifted kids like to look at. It's not just doing the calculation, that's doing the math. We actually want to see this mathematical thinking come out and these bigger ideas come out. And that's discovering things. And once the kids learn how to discover, boy, their confidence goes up and they get really excited. So now let's go to the next part of this webinar, and it's explaining the concepts and linking them to new concepts. So let's start talking about metaphors in mathematics. Now, metaphors, the use of language is actually huge in mathematics, and particularly for the younger children. So we're going to look at a couple of very basic metaphors so that you understand how important these are for building the understanding of mathematics. First of all, I'd just like to go into the subtraction. Now, here's an example. Your child comes home, he's in grade 1, and he's just learned subtraction, or she's just learned subtraction. And you sit down and say, oh, I can help out with this question. So you sit down with your child, and you say to them, oh, let's do subtraction question. You have 7 minus 5. And when you do the question, the child looks at you and goes, I didn't do minus. And that's what they're thinking inside their head. And you ask again, well, you've done this in class. What's 7 minus 5? And the child is looking at you and trying to figure out, well, what am I supposed to do with this? I've done takeaway. I haven't done the idea of subtraction or minus. And so you just have to use your language as the same as your child's language. That's the first thing I want to say to you, is please start with what their language they're using, because their language has meaning for them. So let's look at the metaphors for subtraction. They start with takeaway. There's also minus, there's difference, there's distance, and what do you have more of, and by how much. So you can see there's a lot of different ideas here and different concepts. Let's first take the takeaway concept. This concept is always we start with this. Kids understand takeaway, because if someone takes away something that they value, they don't like it, and so it's an emotional effect on them. So if they understand it when you apply it to mathematical ideas. We have 7 things. We're going to take away 5. And what are you left with is 2. So notice my language, taking away, left with, and that is what subtraction is. And that forms the foundation for subtraction for kids for many, many years. But then we get into this idea that subtraction is also a difference. 7 minus 5. Well, we've got a difference between 7 and 5 of 2, which you know that. It's quite clear that that's the difference. But when a child learns this, first they could be in grade 5, grade 6, or even grade 7, and they get a question, a math question, where it says, hey, what is the difference between this number and that number? And the child's wondering, well, what am I supposed to do with this? And the teacher just says, well, subtract. It's just a subtraction question. So now what they've done is they've learned, I've got a subtraction question, which I thought was takeaway all this time. And I've learned this concept. So they've got this concept over here. And now all of a sudden they're told, oh, subtraction is also difference. Now I have to remember 2 different things. And in fact, the bright kids and the high-performing students will automatically link these 2 ideas together and understand why you can understand it one way and the other. So let's just look at this for a second. If you took away that which is the same, notice my language. Take away language, and that's 5. If you take that away, then what's left? Well, you've got 2 left over. And that concept, that's the difference, because you're taking away that which is the same, and what you're left with is that which is different. So this is why we come up with the word difference, because that's what's left. All right, now what you've done is you form those 2 together, and in a problem-solving kind of question, it could present itself in one way, but you actually have to answer the question by using the other conceptual understanding. So this is critical that kids understand how to do this, and that you as a parent or as a teacher understand when this is happening, that the metaphor itself has changed, so there's a different understanding, but yet it works together. Once the kids understand that subtraction is also a difference, then when you ask them to do something like 31 minus 29, all they have to do is say, well, what's the difference between the two? Well, there's 2 more. So the answer is 2, rather than trying to put it in an algorithm and carry and do all these other things. Okay, so now you can see the difference between 5 and 7 on a number line. You can use that idea as well. So you can apply this idea of metaphors to all the basic operations: addition, multiplication, division, exponents. And when you are explaining it, be aware that there are different metaphors. That's really what my point is here, because it forms a different conceptual understanding of what's happening in mathematics. So the next thing I really wanted to talk about was the importance of procedures. It's important that kids do learn the procedures. It is not that they learn just the conceptual ideas or the procedures, it's both. Keeping high standards, you have to be exact and consistent. We give large numbers, and kids like large numbers. It's the same concept. It's just that you're doing it over and over again with more numbers. And the reason why they like large numbers is because it's a little harder to get the exact correct answer at the end. And this forces them to a higher level and a higher standard. Now, they also, another thing that we do, and these kids really like, is that you build the procedures very slowly so that they appear obvious. Oftentimes, we think that the high-performing student needs to be given something much faster and explained much faster, and you don't have to do the foundations. You do have to do the foundations just as slowly as any other child. It's after that that you can apply, and the kids just fly. So if we look at this example, this would be at the very top. It says 3 divided by 7 times 56. The kids learn how to use the relocation property to move the numbers around so that the operation sign stays in front of the number. So with the 3, it'd be 1 times 3. They understand the identity element. And so when we move this around, you can calculate it very easily. They work with little equations like that first one to begin with until they get very good, because they can move those numbers around. And then we add on the numbers. Grade 5, you would see something like the 9 divided by 8 divided by 7 and so on, that whole expression. And they learn how to move the numbers around so that they divide into the other numbers nicely. And we do give numbers that work so that they're building their skill sets, and they learn how to work with numbers and see that the 22 isn't just 22, it's 11 and a 2, and how can you use those, what the number consists of. So as they're developing that gradually, we keep adding more numbers, so we make it more complex. Notice this is just multiplication and division. We will also do questions like this, which is addition and subtraction. And then when we combine them together, they're able to do questions like this in grade 5, where you even add in the exponents. And you've got multiplication, division, addition, subtraction, exponents, brackets, all mixed together. But we do this gradually so that it appears obvious that that's what you would do. And the procedures are important. Now, don't just do the math. Please teach the kids how to think mathematically. I've been talking about this quite a bit. In this next idea, I just want to talk about this as new ideas, and even a very basic idea, so that you can develop ideas in a much bigger way. So the very first one is the greatest common factor. The first thing is to list, and we actually talk about this with the kids. What's the idea about greatest common factor? Well, it's not just that you're trying to find a greatest common factor, it's the fact that there are relationships between numbers. And one of the relationships are the common factors. And then we can ask for, oh, that's kind of cool, they have numbers in common for the factoring. And then you say, well, what's the greatest one? Can you find the least one? Well, it's always 1. And so what's the greatest? Well, in this case is 1,218. And we just find this out by listing the numbers. So the idea is that there's this relationship. And so if we can list the numbers, is there another way now to find the greatest common factor? And it's the use of prime factoring. Well, why does prime factoring work? Well, the prime factors of each of these numbers give you, all the combinations of the prime factors give you all the numbers in that list. So then we can use this, and it's the idea behind that that's important, so that kids learn the procedures afterwards. But if they just do this without really what's the idea, then they don't form the mathematical thinking. From here, you can even, I'm going to go a little deeper with this because it is the idea. We can do the greatest common factor using a difference of two numbers. And why does that work? In this case, it actually works. It doesn't always work. And so we ask the kids this question. This is the largest possible factor. Why would it be the largest possible common factor that will divide into both? And that's the idea of mathematical thinking. So I'm going to explain this really quickly for you because I know I don't want to leave you on the edge wondering about this. Very quickly, if you look at 12 and 15, if you're already at 12 and you need to skip count over to 15, that's a difference of 3. Now, if 3 will go into 12, then you know for sure it's going to go in 15. And so it actually happens to be the greatest common factor in each case. It cannot be larger because let's say the factor of 12 is also 6. When you skip count 6 from 12, like if you skip count up another 6, well, you end up at 18, which is too large. So the largest possible factor can only be 3. And it happens to be the greatest common factor in this case. So let's look at 12 and 21. The difference is 9, but 9 is not a factor of either one. 9 is not a factor of 12, even just to begin with. So it cannot be 9, but it has to be then a factor of 9 because it has to be divisible by 9. It has to go into that somehow, so you can skip count up. The factors of 9 are 1, 3, and 9. And 3, try 3, it works. That's what works. So now we get to the 12 and 33. The difference is 21, and 21 is not a factor of either one. So what are the factors of 21? Well, you've got 1, 3, 7, and 21. You try the next largest number, which is 7. 7 does not divide into 12, so it won't work. And so you try the 3, and those will be the only ones that will work. So the ideas, notice how I came up with one idea to begin with in the last slide, and then we developed it out. This is a type of thinking that high-performing students really enjoy. It's not just doing the math, it's actually thinking mathematically. So another example, which of these rational numbers is the product of the other 6? We give this to our teachers as part of their coming in and our screening for them. And what we want to see is that they're not going to just try to cancel out and try different numbers. We want to see if they've got the idea that if we are looking for the number we're looking for is n, so one of these numbers is going to be that number that equals everything else, then the product of all the other numbers is n. Okay, if the number we're looking for is n, then the product of all the other numbers is n. Then if we multiply n by itself, we get n squared. So basically, if you multiply all those numbers together, you get n squared. So that's what you need to do. That's the idea behind this. It's not just a trial and error. Because if you've got that mathematical concept, then you can get the answer. So much easier. And in fact, if you multiply these all together, you get 10 squared over 11 squared, or 100 over 121. You just take the square root and you find that the number itself is indeed 10 over 11. So that's the end of my webinar. We've just taken the part 2 of addressing the needs of high-performing students. And you've seen the specific strategies to use when sitting down with your child. I've looked at the drills, how to develop a sense of discovery, your language, and procedures. And then finally, I talked a little bit about the ideas to develop the mathematical thinking. Now, as I stated in part 1, our mission is the basis for all that we do, and I do need to mention it again: to promote cooperation, inspire confidence, and release the genius in every child. Notice that it doesn't say anything about a specific topic. Everything I talked about in this part 2 is to do this. We believe that when you create good thinkers that can communicate with each other, that they will have greater confidence, and we will be able to release the genius in every child. And now I would just like to talk about part 3. So in part 3, we're going to develop the strategic thinking skills and strong reasoning. I'm going to show you how you can problem solve by linking one concept to another, how we build on the reasoning from a younger age, and we build it up each year by year, and then also to develop a multi-year problem solving program. Now in part 1, if you missed it, what I talked about was the gifted versus high performing and the misconceptions and how to work with those students. And I also took some resources, so you may want to go and have a look at it if you can. I'd like to thank you for listening to this webinar. I hope you have learned something and that you can take it away with you and apply it to what you are doing. Thank you.